Hi, my name is NURUL IZATIE BINTI TAJUDIN. My MATRIC number is 230951. So now, I will present the topic, which is fluid properties and their engineering applications. What are fluid properties? Fluids possess different properties of different bases which can be used to characterize the fluids. These properties help describe how fluids behave under different conditions and are crucial for understanding fluid motion and interaction with other substances. So now, I will present the main fluid properties, which are viscosity, compressibility, and surface tension. The first types of fluid properties is viscosity. Viscosity is the internal friction of a fluid caused by molecular attraction which makes it resist a tendency to flow. For example, a customer can sense the viscosity of a food product such as honey when it's too high or too low. In pipeline design, viscosity affects the pressure drop required to transport fluids. High viscosity requires more energy for a higher pump power to move through pipelines. For example, transportation of heavy crude oil through pipelines from the point of production to storage facilities or refineries. The second fluid properties is compressibility. The compressibility of a fluid is a measure of change in volume and density when the fluid is subjected to a change of pressure. The usual quantity used to measure this phenomenon is the bulk modulus of elasticity, or simply bulk modulus E. The applications of compressible fluid flows are vast and significant. For instance, the fluid flow in gas and steam turbines are treated as compressible because its density changes during the flow due to variations of pressure and velocity. The expansion of compressible fluid affects the energy extraction to make it efficiently interrupt pressure and extract the work. The last one of fluid properties is surface tension. The definition of surface tension is measured as the work per unit area required to move lower molecules to the surface of the liquid. For example, the surface of a liquid in a small diameter tube will assume a curved shape that depends on the surface tension of the liquid. Surface tensions of working fluid plays a very significant role in the performance of pulsating heat pipe (PHP). When the surface tension is greater, the maximum allowable tube's diameter and tube's pressure will increase too. Although a larger diameter will result in a better performance, a higher pressure drop needs more pumping power. Thus, a higher heat input needs to maintain the pulsating flow. A common engineering issue arises in the transportation of viscous fluids. For example, a heavy crude oil or polymer solutions require a higher pumping power leads to increased energy consumption and a higher operational cost. For a high viscosity of fluid, it will increase in resistance, require more force, increase friction and wear on seals, potentially causing leaks. And high viscosity can restrict flow rates in pipes or other components. For low viscosities of fluid, it more effortlessly making transportation, pumping and other movement-related processes more efficient, but often need precise calibration to ensure optimal performance. Fluids with too low a viscosity may not provide adequate lubrication, so the engineers come with some solutions which are diluting the liquid with a solvent or other additive, the use of heater, coolers or viscosity modifier, and specialized pumps with enhanced power. We have reached the end of the video. In summary, these fluid properties are fundamental to many chemical engineering applications. Each property affects processes in different ways and also influencing decisions in equipment design and process control. As technology advances, the continuous study and application of the fluid properties will remain essential in the pursuit of industrial innovation and sustainability. That's all from me. Thank you.